All right, yeah, go.
All right. Daniel standing. Although there seems to be nothing happening, there are multiple forces at work. The ground Daniel is standing on is pushing against him, but Daniel is also pushing back with the same force, canceling the forces out, making the net force zero. This concept is explained in Newton's third law of motion. For every action, there is an equal and opposite reaction. Daniel throwing the football. Right before Daniel throws the ball, he applies a force on it, causing it to move, thus doing work on the football. Ball in midair. Once the football leaves Daniel's hand, it becomes a projectile. As it is moving, its horizontal speed is constant, but its vertical speed is being accelerated by gravity, which is 9.8 meters per second, near the surface of the Earth. For a split second at the top of the trajectory path of the projectile, there is no vertical speed, and there is only horizontal movement until gravity begins to pull it down. Daniel catching the ball. Right before the football is caught, all of the potential energy and energy gained by the force of the football is all kinetic energy. It is possible some of the energy was lost in heat when considering air resistance, but it wouldn't be much. If Daniel catches the ball suddenly while it still has a lot of kinetic energy, he changes the ball's momentum in a short time by a big force, which might result in some injury to his hand. But if he changes the momentum by a small force over a longer period of time, there will be a lesser chance of injury. Daniel running the football. With the ball in hand, he begins to run the ball back. There are two kinds of friction. Static friction is presented before motion begins. As more force is applied to an object, static friction builds until motion begins and kinetic energy replaces static. Daniel wears cleats to help the friction remain static friction, so he doesn't begin sliding. He runs the ball in for a touchdown, and the imaginary crowd goes wild.